Module 12, we're going to be doing 12.3, the distance formula. Today you will understand how to use the Pythagorean theorem to find the distance between diagonals on the coordinate plane. So we pick up with the Pythagorean theorem, but now we have right triangles on the coordinate plane. Then we will understand how to apply the distance formula, similar to the slope formula. Simply take some roots to find the distance between points on the coordinate plane when the Pythagorean theorem is not a viable option, or when we're just given 2 points and we're asked to find the distance. So here now we have a coordinate plane. We have a whole bunch of dots, and we're being asked to find the distance between 2 points, point B and point C. Now, as you can see, I also have a right triangle here, which means that technically this diagonal here, the longer side, functions as the what? Functions as the hypotenuse. So if you know the length of these legs, are you able to find the length of the hypotenuse? Yes or no?
Yes.
So in order for us to do that, we have to find the lengths of CD, the bottom leg, and BD, the leg on the right-hand side. To do that, to measure the distance, to get the length of the legs, you simply start at one dot, 1 point, and you count how many units you move. To go from here to here, how many units is it? 2. It's 2 units. 2 units. Then we look at BD. It's starting at point D or point B, it doesn't matter, just count the distance between them. 1, 2, 3. So it's 3 units apart. Once we identify the measures of the legs, we can then go in and substitute these values into the Pythagorean theorem to find the distance between points B and C. What would my equation look like?
2 squared over 3.
2 squared plus 3 squared equals C squared. Now the reason I can do this is because these points altogether form a right triangle. And we know that if we know 2 lengths of a right triangle, I can find the third length by solving. Some of you are saying, well, can't you just kind of count the distance there? It's not going to be exact because it's a diagonal. Horizontal and vertical lines, we can get an exact distance. But a diagonal, you can't get the exact. As you will see, you can guesstimate it, which is a guess and an estimate, but you won't know exactly. What's up?
So in finding like the length for CD and BD, all you have to do is count the units if they're straight?
Yeah, from C to D, that's a horizontal line. So from here to here, it's 2 units. From D to B, from here to here, it's 3 units. That gives us the length of the leg. We can then find the length of the hypotenuse. This gives me 4 plus 9 equals C squared. So 13 equals C squared. You then have to go in and take the root of both sides. So what is C to the nearest hundredth, approximately?
3.605.
3.6, we'll say, okay, so nearest thousand, 3.605, ... because it's a non-terminating, non-repeating decimal. So now if you were to guesstimate this, you would have said, I would have said it looks like it's about 3 something. But to get a clearer estimate of this distance, we substitute these values in the theorem, take the root, and we know it's approximately, that's this little wavy equal sign here, it's approximately 3.605, ... It kind of goes on from there. Any questions on the first one? Now in the second one here, you're just given an empty coordinate plane. You're not actually given a right triangle like in the first example. But we want to find the distance between points A and D. I don't have a right triangle right now, but can I draw one in, yes or no?
Yes.
Yeah, I could. The first thing you want to do is you want to connect points A and D with what type of line?
Horizontal, no vertical.
Can't be. A to D, what type of line is that? Starts with a D. A diagonal line. That's going to function as my hypotenuse. And then you need to draw in a right triangle. There's 2 ways to do it. You can start at either point and connect them at a right angle here, or you can start them at either point and connect them at a right angle here. Either way, you're going to get the same measurements. So I'll draw the triangle below. Remember, you're drawing in a right triangle. They should meet at a perpendicular angle. Once I draw in my right triangle, we draw a diagonal line, and then we connect them with a right angle right there. Once I draw this in, I can count the units between these points. Here it's 1, 2, 3, 4, and here it's 1, 2, 3, 4, 5. So now that I know the length of my legs, I can substitute these into my theorem, and I can solve for the missing measure. So what is my equation going to look like, class? Liana?
4 squared plus 5 squared equals
we don't know, the hypotenuse, which would be c squared, right? So this becomes 16 plus 25. What is 16 plus 25? Anybody?
31.
41. So 41 equals c squared. I'm speeding up the process here because we know we have to add them. I then will take the root of both sides. And the root of 41, is that a rational or an irrational number?
Irrational.
Irrational, because that is not a perfect square. So what is c going to be approximately? 6.403 dot, dot, dot. It's approximately, wavy equal sign, approximately 6.403, non-terminating, non-repeating decimal. If you're wondering where I got the 41 from, I squared them, added them together, gave me 41. At this point, we should know we have to square these and add them together, so I'm speeding up the process for you. Any questions on this one? Any questions? Okay. So we'll pause there. Actually, we got 2 minutes. We can finish that and we'll do the whiteboard after lunch. This one, similar. We got 2 minutes. This one is similar to what we've done, except this is a real world problem. Here, they're giving us the right triangle. We're being asked to find the distance on this map for George from here to here. The only differences between the problems that we've done and this one is you have to be very careful with the units. As you can see, these are not going up by ones. What are these going up by? Hundreds. What are we starting at? 50. So to find the length from here to here, 50, 100, 150, 200, 250, 300. So the bottom leg is 300 units. And this is also going up by hundreds, but in between it is 50, 50, 50, 50, 50, so it's going up by 50s. 50, 100, 150, 200, 250, 300, 350, 400. So the other leg is going to be 400 units. Once you identify the length of the legs, we can then find the distance between these 2 points. What is my equation going to be, Kian?
300 squared
300 squared
plus 400 squared equals c or x.
equals c squared x squared. That's going to give me 900 plus 1600 equals c squared. I add these together. This is just a much bigger version of 3 plus 4 equals 5. Watch this. We take the square root of both sides. What's the square root of 2500?
50.
50. It's a rational number. So c is equal to 50. I don't use the wavy equal sign because it is exactly 50 units long. So from here to here is 50 units. Question?
I don't understand how you got 400 for the right side.
So here, this started at 50, right? And this ended at 450. So I went up in increments of 50. 50, 100, 150, 200, 250, 300, 350, 400. Just realize that you always have to kind of identify what the graph is increasing by. Any questions? No? Okay. It is not always easy to identify the lengths of the legs. If we look at this right triangle here, it's possible to identify the length of the legs, but it's not the easiest prospect in the world. When we have something like this, or later on when we just have 2 coordinate pairs, it's much easier, and sometimes the only way we can solve for the distance is to use something known as the distance formula. The distance formula is what you see in this box right here. And it says the distance is equal to the square root of the x-coordinate minus the x-coordinate squared plus the y-coordinate minus the other y-coordinate squared. Looks like a lot. You thought the same thing the first time you saw the slope formula, and then you realized it was pretty easy after a while. Same process here. Looks like a lot, it's really not hard. Allow me to make it easier for you. Remember the slope formula, right? We always found what first? The y2. When we're doing the distance formula, the most important thing to find first is your x2. Just like with the slope formula, we liked our y to be the biggest y value. Same thing with the distance formula. We look at the x's, we want the x with the biggest value, the largest, greatest absolute value, to be our x2. So if we look here, we're trying to find the distance between these 2 points. Negative 10, 15, and 20, negative 15. So we're given these coordinate pairs. That gives us this point, and this is the other point. We're trying to find the distance between them. So the first thing we have to identify is our x2. So we look at the two x values. What are my x values here?
Negative 10 and 20.
Negative 10 and 20. Which one is larger?
20.
20. So this is going to be my x2. If this is x2, same process. What does this have to be?
Y2.
y2. That makes this x1, and that makes this y1. So write that in. Remember, it's not the largest overall value. It's the largest x value. That is your x2. The number immediately adjacent to it is your y2. Then everything else kind of falls into place. Once you identify that, then it's just careful substitution. So we take x2, we substitute it in, 20. Keep in mind, there is a subtraction sign in the formula. So it's 20 minus negative 10. 20 minus negative 10. These two negatives next to each other are going to form a positive, okay? And then plus negative 15 minus 15. Keep in mind, we're squaring this, we're going to be squaring that, then we're going to be adding it together. Takes a little practice, it's really not that complicated. So, when we combine these two, we get 30 squared. That's 20. Two negatives make a positive. 20 plus 10 gives me 30. We're going to square that in a second. Over here, negative 15, you combine those, you get negative 30. We're going to square that as well. If you're working ahead, you should realize this is not 30 times 2. It's 30 to the second power. 30 times 30 gives me 900. And then when we multiply two negatives make a positive. So it's going to end up being 900 plus 900. You add those together, and you get the square root of 1800. Once again, that's our little wavy equal sign, because this is not a rational number. So we take the root of 1800, which is approximately 42.426 ... That is a non-terminating, non-repeating decimal because it's an irrational number. So this is not the hardest process in the world. You do need to know this formula because most of these distances on the coordinate plane cannot be done using the Pythagorean theorem. You have to know this formula. It's not the hardest thing in the world. Square root of x2 minus x1 squared plus y2 minus y1 squared. Does take a little practice. What's up?
Will they ever ask us to find the legs?
Well, the legs, I mean, you can find the legs the same way. You can substitute them in the formula. Usually you calculate the length of the legs. If you want to find the length of the legs here, like the bottom leg, you would just use those coordinate pairs as well. If you want to find the length of the leg on the right side, the vertical leg, you could use those
Will they
coordinate
ever
pairs.
ask us to find legs?
Why not? They could. And you would know how to do it, right? Same process of using the distance formula. Questions on the first one? Any questions? All right. So, what if we didn't give you any coordinate plane at all, whatsoever? No coordinate plane, no right triangle, just two coordinate pairs. That's all you have. And you're asked to find the distance between this one and this one. What can you use?
The distance
Formula. Same thing you just learned. So, once again, the first thing we have to do is identify our x2. We're given two coordinate pairs here. Adrian, what are my x values in those two coordinate pairs?
3 is x1,
3 is going to be x1, good. And 19 is going to be your?
x2.
Good, because that's the larger one. So that's my x2, that's my x1. And then what is this going to be?
y1.
y1, because it's next to x1. What's this going to be?
I mean y2.
y2. Once you get that, you substitute it into the theorem. So it's going to be, not the theorem, you substitute it into the formula. D equals, and be careful when you set this up initially. If you make one little mistake in the beginning, everything else is going to be wrong. So D is equal to x2, 19 minus x1, which is 3. Notice I'm not doing negative negative here because that's a positive number. It's just 19 minus 3 squared plus, what's going in? What's going to be the next
45
parentheses?
minus 12.
45 minus 12 squared. And then order of operations, do what's in the parentheses first before you deal with the exponents. So I'm going to have D is equal to the root. What's 19 minus 3? 16 squared plus 45 minus 12 is
42.
33. 45 minus 12 is 33. 33. 33 squared. And then you do a little math, and you're going to get D is equal to 256. And let me do the next one. Let me see if I can do this in my head. So 33 squared, that's going to be 1,089?
Yes.
1,089. We add those together, and we're going to get 1,300 and what? 1,345 is correct. A 6 and a 9, that has to be ending with a 5, not a 2. So 1345. You take the root, and it's going to be what?
36.674.
36. It's approximately equal to 36 point what?
674.
674 ... Irrational number goes on without terminating or repeating. So you have to be very careful in the setup. Then you do what's in the parentheses. You square them, you add them, you take the root. It just takes a little practice. Now, on your FSA, you will not be given the formula. It's one of those ones you're going to have to memorize. There's about 15 that you will memorize. We'll get to all that. Don't worry. I don't have any problem with you memorizing the formulas. Questions on this? Questions? Okay.